Oh, good evening. I hope you can hear me okay. Hang on. I'm a bit loud in my own head there. There we go. Yeah, well, Cobb could hear the music at least, even if Chloe couldn't, so... I'm hoping it's all working. Hello, everybody. Evening, Cobb, Chloe, Jeepin, Majenko. Yes, we had a Majenko. Hope you're all doing well. Not quite a chicken and egg stream here because we can write the keyboard drive. What we might not be able to do is actually hook it up to the Forth. We can write the driver in Forth, but to get to the actual I/O layer, which is currently hooked up to the serial port, I'm not absolutely certain. I had some plans to do that, but they rather revolved around the parts arriving so that I could build an adapter to plug a serial port into the printer connector on the back of the terminal. Hello Carrot House, how are you doing? And happy Friday to you too. So yeah, I don't have those parts, so I can't plug something into the printer port, so I can't get a transcript of what we're doing, which is a shame. I would have liked that. But also, I believe that the printer can actually send status reports back to the host, so I was going to use that as a route to download an updated Forth binary if we got that far. But we'll see whether we get that far or not. And yes, parts arriving are indeed the bane of my life. In this case, it's my own stupid fault. I ordered from CPC, who are usually quite quick. They were quite quick. They got them dispatched the same day, or they sent me the tracking number the same day, but it was for Royal Mail 48, and they haven't moved since yesterday. But anyway, such is life. We'll have it for next time we do a System 1 stream. Incoming ad break in 1 minute, which is interesting because Jeepin was greeted by a burger ad apparently. But Chloe's in the middle of taking advice from Barclays. By the sounds of it, the advice is why don't you just F off? Which, yeah, it's not what you want, is it? Anyway, programming fluid first. So, Chloe, is that because of your chip and sign card, or is this an unrelated problem? Let me get rid of that so I can actually see chat. Exciting. It's almost as if they don't realise they have actual obligations under the Equalities Act towards people with disabilities, isn't it? But I'm not a lawyer, so I couldn't possibly comment, I'm sure. Right, so let's get to it. And there go the ads. So there's System 1, sitting on my kitchen table again, and there is the keyboard. Which is rattling away because it's sort of dangling off the end of the table. It's a bit longer than I expected when I built it. Anyway, so important step that we forgot last time is to press the reset button when the keyboard is actually plugged in. Reset and deposit. And the reason that was important is that the keyboard gets a reset pulse from the computer and uses that to initialize itself by clearing the shift register that holds the key up, key down state, which is why when we poked it briefly at the end of the last stream we did on System 1, we saw some garbage in the queue. That was simply as a result that we'd plugged it in and not reset it. So that was my bad. Oh, okay, the TTS doesn't read that out. I shall fix that. Thank you for the subscription, Wachenko. It is much appreciated, and I hope the abuse your mouth has suffered will at least lead to you feeling better tomorrow. Sounds like no fun at all. Just going to catch up on chat a bit. We have... Oh, I see, Chloe. So it's the card works fine, and then you can't actually do anything in the branch. Okay, that's a particular form of genius, isn't it? And Jeepin, yes, you as well you should feel dirty. I have opinions on the Microsoft stroke Google duopoly on email at the moment, and nobody wants to hear them because you can all guess. But as someone who runs their own mail server, yeah. I am just going to allow Jeepin's comment there about bondage, because why not? Hello Hot Rocks, how are you doing? Cobb, you have a sub to do, please fix the TTS first. Okay, if you insist. Can I do that from here? This has the potential to go horribly wrong, so if the stream dies, it's Cobb's fault. One moment, folks. The reason I say that is I have to actually start Safari, which I haven't. I had to reboot because something was stuck. And starting Safari means it's got to reload all my windows. So there we go. We want this is true, Chloe, yes. It's never advisable to expect things to work on a stream. There we go, we dropped 321 frames apparently, so obviously something did go horribly wrong. Oh, I've tested absolutely nothing for this stream. This is flying completely blind. It's probably not a good idea. Next week's stream will be more thoroughly tested, but we'll get to that later. So I need to log in here with that. And alert box, subscriptions, hang on, let me just check what my text-to-speech settings are supposed to be. Amy full volume, right. Subscriptions. Resub, you can't put a message on a first time sub, can you? So I can't enable TTS on resubs. Okay, let's try it here. If you wanted to try that sub Cobb, it might work now, we shall see. And in the meantime, coffee. I definitely need coffee. Jeevan, I've been accused of worse, to be honest, than being a Tech Tangent stream, but yeah, I think oh no, I'm still delivering 6,000 or 6 megabits to Twitch. That was the recommended setting when I set this thing up. It said I'll set it for 6 megabits. So I did. And now it complains that I'm sending too much and low bandwidth viewers might be overwhelmed. So I might drop it to 5 and see what happens. But I was getting some encoder is overloaded messages.
Cobb 2015 just resubbed for 2 months.
Oh, thank you very much, Cobb. It's much appreciated. I thought you were going to put some sufficiently rude message on that, but obviously not. Yeah, so last time I was getting, or was it last time? Last System 1 stream I was getting some encoder overloaded messages and I fiddled around with the settings and that seems to have cured that. So anyway, let's get back to it. What we want is to bring up the the terminal like that and press the start button like that, and then press F. Oh, that's a shame, Cobb. I didn't actually see it in the chat either, so I saw Majenko's in the chat. I don't know what I can do about that, I'm afraid. Sorry. So we just need to give forth, there we go, about 30 seconds to Thank you, Cobb. It probably hit a censorship thing, yes. There is some crudity filter on the stream. Not you'd know, but anyway. So, fourth, and I should remind everybody that I am by no means proficient in fourth. I can just about find my way around and such like. But anyway, first thing we want to do is to stick it into hex mode because we're going to be talking memory addresses a lot. So, hex. And then if we read from address 8000060, we should find 80. Yes, that's the identification of the keyboard. So the keyboard adapter is present. That much is good. So what we can do now is define a couple of constants for 600. So device 6. So the first one was device 0, which is the I/O board itself. Register 6, which is the ID for whatever's in slot 6. This is device 6, or slot 6, register 0, which is the keyboard status register, and 610 is the keyboard Q. So now if we do a read from keyboard status, it says 0 because there's nothing in the queue. So if we press enter on the keyboard, and spell status correctly, well, this is off to a flying start. Let's press that one. And sanity check. Yes, it can add 1 and 1, so it's not completely dead. Keyboard status at .1. So now there is an event in the queue, so we can read that, which is CC, which is 4C, which is the key code for the return key, with the 80-bit set to indicate that the key has been pressed. And there should still be an event in the queue because there'll be a key up event 4C, yep. And now the queue should be empty. So that's good. Oh, Chloe, that's fun. That means you get to refer Barclays to the ICO for data protection crimes, and then they can join the, 25,000 complaints a year they get, of which they uphold approximately 1. But anyway, such is life. So what we're going to do is take a bit of advice from Majenko last time. We are going to define a word called escape, which prints an escape character, and then we're going to define a word called CLS, which prints an escape, and a bracket, it's 2J, isn't it, and then escape H, and then we should be able to type CLS and clear the screen. So that's helpful. I thought it was. I thought the most recent statistics I'd seen was it was 1 in 25,000 that they upheld in 2023 or 24 or something. But maybe I'm out by an order of magnitude. I quite possibly am out by an order of magnitude. The ICO are completely fucking useless. Cobb, good question. Why am I listening to Majenko? Well, because when he's not whacked out on dental anaesthesia, he usually gives vaguely good advice. Right, so the next thing we want to do is introduce the concept of a deferred word, which is a thing Forth can do. And this is useful because there's a slight problem with the way Forth compilation works for revising code. If we define a basic function which just adds two parameters together, and then we define testfunc which does, I don't know, 10 to func1 .cr, that should print 12. It does. It's in hex, but it's still printing 12. But now if we went back and redefined func1 to multiplication, it still prints 12 because it's using the previous definition of func1. So what we want to do is, let me just see if I can remember how this works. Defer word create do def. Yeah, good. Right. So we can say defer func2, and then func1 is func2. And then try basically the same thing again. Test def func 20. So that now it's using the most recent definition of func1, but we can override that by saying func3 division. And now if we say func3 is func2, I'm mainly doing this so that I can reassure myself I remember how it works, but if we do test def func, now we get 8, which is correct because this is hex, remember, so 10 is 16 divided by 2 is 8. So all that's doing is saying that the word func2 can be arbitrarily reassigned to different words as we need it to be. And that's going to be very useful because it means we can do this. We can write a handle event which takes an event on the stack and does something with it and returns nothing. No, that's not what I wanted to do. I wanted to defer handle event so the thing in brackets there is I can't remember what the exact term is. It's a stack signature. It is just documentation to indicate that this word expects to see a value called event on the top of the stack. And that's before the dash, and then after the dash is what it returns, or what's on the stack when it returns, in this case nothing. But what we can do is now say dot is handle event, and if we say 123 handle event, it should print 123. So all we've done there is say that when we say handle event, we can change that out for something else later, but for the time being it's just dot, which is the print integer word. So now we can write a handle q word, and what this is going to do is take nothing and return nothing. But we are going to say begin, because we want a loop. We want to read the status register, check if the low bit is set, and while it's set we just want to read the event queue and handle it and keep going. So now if we run handle queue, nothing should happen, but if we put a keystroke in the queue, it should print the two events. So it may not look like progress, but it's a little progress. Let me just catch up on chat. Hello, Sworded Insects. Yes, lots of funk going on at the moment, but we've moved on from the funk and now we're onto the nonsense. Funk and nonsense being the best way to spend a Friday afternoon. And hello, Matt. And yes, you will turn into a taco at this rate, it seems. Not that this is necessarily a bad thing. But anyway, so handle queue now can handle whatever is in the queue. So if we type 1, 2, 3, 4. We should see 8 events in the queue. There we go. Which is a good start. And then we will write another loop. And all this is going to do is... I have just forgotten whether I can do what I was about to do. 1 second. Begin... Can we just do begin loop part condition until? Oh, begin again, right. So all we want to do is say begin handle queue again, and that should just sit in a loop, spitting out events until we interrupt it with the reset button or the interrupt button. Let's have a look. Cider is always a good thing on a Friday as well. Good thing most of the rest of the week as well, but it depends whether you've got work in the morning. And Cobb, yes, going too well. It's there is still time for it all to go horribly wrong, which I'm sure will happen. But what we need to do now is figure out how we're going to convert those scan codes into actual characters. And to do that, the first thing we're going to need is a great big buffer to hold a table. Now, this fourth defines a word variable which is used to allocate one word as a variable, but that's not what we're going to want here. We want a we need rather a rather larger thing. So sorry, brain is about to fail. We need a 128 keys on the keyboard. We want, for reasons, a 256 byte. So we'll make sure we're in hex. Well, we're definitely in hex. But we can do that with 100 alloc, because again this is hex, remember. So 256 bytes. Allocate that, and then define that as a constant KB table. Parse error. Y. Oh, because it's a lot. Right, good. So that is the address of our table, and if we dump that, which I think we do with KB table 100 dump, yeah, it's full of nonsense. This is just random noise from memory. Hi RHK, how are you doing? I shall look forward to you joining us when you're free. Now, we can't go referencing into that table because it's a mess, so we want to define a something to clear it. So let's define mem0 adder len like so, and then begin. Duplicate the length if it is greater than 0. So while it's greater, what? Forget mem0 words. Maybe there isn't a greater than 0. Oh, whoops, yeah, okay. Mem0 adder len. The convention, of course, is the 0 goes there because it's as if you're pushing the 0 on the stack and then you're doing the comparison. Right, while. So we need to say subtract 4 from the length because we're going to be writing 4 bytes at a time. Swap it so that you've got len adder. Duplicate it. No, 0 over right. So that should put a 0 at adder. 4 plus swap, and that should now give us adder len, so we can go back to the loop. And I forgot to indent all of that, but anyway, so if we say KB table 100 mem0 and then dump it again. Good.
RHK77 cheered with 100 bits. Less than my obulus for being late.
Oh, thank you very much for the 100 bits, RHK. Much appreciated. That reminds me, actually, I was completely wrong on Tuesday when I was talking about whatever the financial split is of bits on Twitch. I get 1 US cent for every bit cheered. So it basically works out. Twitch's cut is whatever they cost you minus 1 cent. So I think Twitch gets about 30% if you're buying them in the UK undiscounted, something like that. So anyway, they are much appreciated, regardless, including Jeepin's single bit. I feel bad that I made Jeepin feel bad about that, or at least pretended to. Right, so we now have an empty table of scan codes. And what we're going to do is put ASCII in it. And to do that, we are going to copy strings into it. Let me just have a look at my notes here. So if we have a string in fourth, a string looks like length at the top of the stack and the address afterwards. Okay, that's fine. And there is a cmove word which can be used for copying stuff around. Let me find it. No results. That's interesting. Oh, because that's in mine, not in JonesForth. Forth.asm cmove. So, length on the top, destination source. So we can define a word called KB codes taking what does it need to take? It needs to take the address and the length of the string and the starting code where it should be put. So to do that, we do Add address length code. So we need to swap that over so that we've got address. No, we don't. Hang on. Have I... I'm looking at my notes and they're not making as much sense as I thought they did. Code length address. Yeah, so we want to add... Oh, right, yes. We want to do KB table. So now we have address, length, code and table on the stack. Want to add them, which gives us address, length, destination address. And then swap them so that we have address, destination and length. Yeah, and then we can just do a C move. To write the whole lot into memory. So we can test that by doing S P and then bracket bracket. And I think 40 is the yeah. 40 is where the Q row starts, so if we dump that table we should now see, there we go. So starting at 40 in the table, we have the first line of the keyboard. Just have a quick look at chat. Food does sound good, Chloe. I have to worry about that after stream, I think. Yeah, yeah. You do have to get your head around it a bit, which is why you have to make all these marginal notes. Anyway, we can move on and write the other rows of the keyboard into the table, and we want a hash at the end there, don't we? Yes, and that starts at 60 and backslash. Yep, and that starts at 10. Now this is somewhat embarrassing actually. The reason all these numbers are a bit strange is that I designed the keyboard to start with escape being key 0 and then run 1, 2, 3, 4 along the top here, and then this was row 1, 2, 3, 4, 5. And then I accidentally scrambled the order of the bits going into the decoder, the row decoder. So all the rows are swapped around, which is unfortunate. So I need a crib sheet for where stuff belongs in scan code order. We're also going to write a KB code word, which is just going to be to write one entry in the table, and that's much simpler. Given a value and the code point at which to write it, it's just KB table plus cbang. So now we can do 20 is a space, isn't it? And where is the space bar? the spacebar is at 37. Let's put escape in for good measure. That's definitely a 0 because at least 0 stayed the same. And we'll put an A in for C for the carriage return. And now, if we look at the keyboard table, it should have more data in it. Okay, so keeping an eye on chat. I don't know, Jeepin, why are you watching a VW commercial in French? So I just want to remind myself what I call the handle event. That was it. So if I see handle event, that should just handle event is a dot. Great. So now we'll have a. I'm just wondering what to call this. We wanted to find a new word for handling events with that table that we've got so far, which is just the uppercase ASCII set. Let's call it simple handle event. Oh, and I forgot the stack signature, which is, come over here. Oh, it's simple enough, it's just event, isn't it? Oh well. Right, I'm just looking at chat and wondering what on earth has gone on now. But it's good to know, Matt, good to know. So, given that table that we have at the moment, what we want to do is look for the key down event specifically. So we've got an event and we want to say duplicate 80 and that gives us event and is key down. And what we'll say is, if it's a key down, then we want to mask it with 7F, which leaves us with code. Add it to the keyboard table pointer. Read it, and then if it's not 0, queued up if omit then. Yeah, so if it's not 0, duplicate it, pop that with the if, omit it if there was anything left, or omit it if it wasn't 0, and then we're done. Otherwise we still have to drop that code, so we'll drop it and say then, and we'll test that with, what did we say Q was? Q was at 40. So if we say 40 simple, if we say CO simple handle event, it should print a Q, and if we put in the 40, which is the key up event, it should do nothing. Good. So now we can say simple handle event is handle event and test loop, and in theory we cross our fingers and we type HELLO. Well, that much worked. shift doesn't work, so we get ones, but anyway. And we need to break out of that. Slices of spam now, are we? Pineapple on pizza with extra tuna. I mean, you know, I've eaten worse. Anyway, so we have enough of a thing working that we can type in uppercase ASCII. So we're about on a par with Shelby's lesser dasher at this point, or certainly the lesser keyboard. So we need to get on with or what we want to handle is shifts, don't we? So go back to my notes, which I know you can't see, but that's because they're a mess. And we are going to start by overwriting what we've just done with the lowercase versions. We still need the backslash, so it's... Well, I suppose I could have just added the one there, couldn't I? But anyway, it doesn't matter. That should be, if we now do a test loop, we should now be typing in lowercase. If I could type, which I cannot. Good. And we want to add the uppercase versions of everything, or the shifted versions, in the upper half of the table. So by adding 80. At least I have all the keycaps, yes, and lots of them. They're not a matching set though, unfortunately. I still need to get around to taking all the ones I've been using for the last 5 years off my keyboard in the office, and then replacing the main set with those so that they match the extra function keys. So now we want to write the shifted version of everything in at, so 40 plus 80 is CO. Let's just get this right, because the keyboard layout on the VT240 does not match the keyboard layout on System 1. That's at 60, so DOEO. We need a pipe, yep. No. That one, that one, that one. And that needs to go at 90 KB codes. Why is the uppercase K looking crumbled? It's not the best font, is it, actually? I hadn't noticed that before. That's just DEC being DEC, I imagine. I don't think this one has quite the same fanciness that some of the other terminals had with... I think it was the 110. Did something nice with half-pitch dots in between, or something to improve the topography, but this one doesn't, unfortunately. So let's just make sure those are in the right place. KB table and oh, we need the punctuation row as well. Okay, that'd be handy. Punctuation row. We're going to have to come back and put the double quotes in later. Hash and that lives at AO, yep, KB codes, which means we want to put a bear with me. I should know this, it's 22. 22 needs to live at 21, I think. No, A1. And we also want to put space back in at 37 B7, isn't it? KB code. So let's try that again. KB table 100 done. So we should now see the punctuation row show up after the low row. Yes, it does. Good. The double quote is in the right place and the spacebar is in the right place when it's shifted. Oh, and shift enter as well. Where was that in the table? A was at 4C, wasn't it? So we want A at CCKB code. So it should be after the good. So we have a shifted character set in the code, which is good. X is the same. Yeah, so yeah, I think it's just the font resolution in the VT240, unfortunately. But I like it, so I'm sticking with it. The alternative would be doing all of this in a terminal emulator, which is just boring. Jeevan, I do apologise. I'm not great at explaining things as I go along. It's all in my head, and trying to get it out is the tricky bit. But what we've just defined basically is a 256 byte table which contains the ASCII values of all the printable keys on the keyboard, or in the main set, main alpha set. The bottom 128 bytes are just the unshifted ones, and the top 128 bytes are the shifted versions. And that'll let us excuse me a minute. I made this coffee a bit stronger than I intended, so I'll drink more of it. That'll help. So we can now define a new event handler routine. I've just realised my mic's a bit higher than it should be. And that one will be able to keep track of the state of the shift keys so that we can type upper and lowercase and be all fancy about it. So to do that, what we need is to define a variable shift state. Let's call it shift state. And if we read that, it should contain garbage at the moment. There's a lot of garbage, okay. 0 shift state. So we should be able to clear it. Good. And then what I think we're going to do is put entries in the table, because ASCII of course is a 7-bit character set. We can use the top bit to indicate special keys that need to be handled differently. So what we'll do for the time being is just put left and right shift, put some sentinel values in there for that. For tangent, do I have a part number for these toggles? They're from NKK. I don't remember offhand. I can definitely look that up though. Yeah, sure thing, Sleepy. Hang on, have I said hello to Sleepy yet? I don't know if that's your first comment so far this stream. If not, hello, good to see you. But sure, pick my brains all you like. RHK, I'll dig that number up and get back to you at some point. I want to say GW17 something. I can tell you exactly where in the pile of junk upstairs the box they came in is. So, yeah. And then the push, the tact switches are Onron B3J. I remember that one easily enough. So what we want to do is add some Sentinel values for the two shift keys. So we can do that with whereabouts in the keyboard matrix are the shift keys? I'm just looking at my notes again. Right shift is 1B. So let's call keyboard code takes value and a code. So let's put F1 in 1B. So key down is will that work? Yeah, should do. And F2, where is left shift? Left shift is, I'm going to have to count now. If that's 30, 1, 2, 3, 1, 2, 3, 3, 3. Okay. I'm just glancing through my notes to see how I was thinking about approaching this. So we can write a new simple handle event, shifty handle event. Whoops. Let's try the colon, that will help. And we'll start again by saying duplicate it and ending it with 7F so that we have event and key code on the stack. I've forgotten what I call my variable. 1 second. For the dual serial board, the resistors are just my R1, R2. Did you have other pictures on the site to figure out their values? For the dual serial board, I think they're all the same. So yeah, yes, we looked at it on the. It was 1K. There was nothing on the schematic I found. The schematic I found just had R1, R2, etc. as well. But the picture on the site was brown, black, red. Terminal software I was using on the Mac to connect the system was something called CoolTerm, which is cross-platform, and I quite like it because it isn't it's not really a full-blown terminal emulator. It lets you do stuff like send random hex as well and view the incoming data in hex. It has its quirks, but I like it. I like it a hell of a lot more than Minicom, which is everybody else seems to use, and then act surprised when it gets in the way. Thank you for Dead Insects. Always good to have chat as a backup memory. Shift state, and we want to read that. And if any of the shifts are down, then we'll add 80 to the key code. So now we have an event and a shifted key code. Whoops, that would have gone horribly wrong. We need the then there. Now we can read from the table. And that gives us the event and ASCII. I think this might have just blown up in my face. Maybe I got away with that. So now we want to do the swap and the 80 in the end, so that we have the ASCII and the key down flag. And we shall. Oh no, we still need to handle the actual shift, don't we? Yeah, exactly. A sword and insects. That's why I like it. It's you can enable things like handling backspace character and the bell character, and that's about it. And clearing the screen on the form feed. But yeah, for doing embedded nonsense or hitting unknown devices, it's great. Something is honking at me, and I'm not sure why. Bear with me. Oh, it's RF Programmer on Discord. Okay. Sorry, I just need to catch my train of thought here. I think I have a bug, but it doesn't matter. We shall press on and see what happens. So we can say if, so it is a key down. Then we have ASCII, so we can do Q. Yes, Phil. The late arrival, unfortunately. But good to see you. How are you doing? Right, what we need to do is it's a key down, so we need to duplicate it and see if it starts with the F. Yeah. Right, great. Then duplicated FO and. So if it's F something, then we want to just get the F and all that with shift state. And update the shift state. Otherwise, it's not F something, so we want to Q up it. If it is something, then emit it. Otherwise, we're done. Yeah. Now it's a key up event, so what we want to do on a key up is again check if it was a shift key. If it was a shift key, then trim off the F at the top, read shift state. No. Invert, read shift state. and it update the shift state. Otherwise drop. Now that yeah, Majenko, you make a good point. That might well work. I was tracking the two independently. But you can just keep track of how many shifts are held down, can't you? Okay, well, we might rewrite this in a minute then, because this might be completely broken. So what we can do is shifty handle event is handle event and see what happens. Complete crash. Okay, good. We could interrupt it and we haven't lost anything. That is definitely good news. Let's just double check we haven't trashed memory. Yeah, I think Majenko is quite right that you can just count how many shifts are down. Yeah, okay, so let's do that. And let's write this in a slightly more we'll break some of this out into smaller functions as well, make it a bit easier to reason about. I'll just catch up on chat. Phil, I approve of the Scampi. I do not approve of accidentally ordering a 10-inch rack shelf. That sounds like it's a useless rack shelf. So let's forget shifty handle event and let's update the, if I can find my notes again, it was 30123. Sorry, yep. So we'll put FO at, and we'll put it at our right shift 1B. Do we need to do that on, for good measure, let's put it at the shifted versions as well. So that if you're holding down one shift, the other one works. Yeah, the reason I was tracking them separately was because I was worried about if you're holding one down and then tap the other one, would it get confused? But of course, if you just count, then it's you could even use the saturating counter; it would be fine. So we'll do this a bit differently as well. We shall write a new word, handle shifts, handle specials, and NOP. No, that's not what we wanted. And what drop is handle specials. So that'll make life a bit easier, because what we can do is just write that shift handling stuff later. Actually, let's think about the structure of the code. If it's going to say we're going to want to go in there with the shift value, and we might as well do the decoding of the, so we'll say to drop is handle specials. Right. shift state. I mean, yeah, I too done for. I know the feeling. When I first wrote this, I did a chunk of work. I did eventually manage to get it to print a directory listing from a compact flashcard, and then I had to lie down in a dark room for several hours to recover. So we have an event on the stack. What can we do with that? We want to first duplicate it and mask off the low bits, which gives us event and key code. And then if we swap 80 and, we have key code and is key down. And we'll swap them back. And then we'll say shift state. If the shift state isn't 0, then we'll add 80, which gives us key down and shifted key code. Yeah. Then look up what's in the table at that key code, which gives us key down and an ASCII value. Okay, key down and an ASCII value. So let's say duplicate the ASCII value and hand it with FO, and if the answer is FO, so we have key down, ASCII, and is shift. So if it's a shift, then we want to handle specials. So that then consumes the key down and the ASCII, so the two drop effectively, and then we are... So all the special handling is done there, and then we can exit this routine, so that's good. So now we have on the stack, we have key down and ASCII. So you want to swap if. So now we're handling a key down, and we'll do the q.if emit then to print the ASCII if it's not 0. If it is 0, then we just drop it. If it's not 0, then we print it. Otherwise, we drop the key down. Otherwise, we drop the ASCII value from the stack, and we are done. I don't like the way I've written that. Swap if q.if emit then else drop then. So I think that might be better. Let's try it. Shifty handle event is handle event test loop E. Right. So we are back to where we were. In that we are printing in all uppercase. Why were we printing in uppercase? That should have been lowercase. What's in shift state? 8. Okay. Good. So now we just need to write the handling of the shifts. Even it does look a bit like that, doesn't it? It's just pseudocode written by an absolute lunatic. I've just realised I don't think I actually explained at all what this at and exclamation mark nonsense is. At is how Forth writes what in BASIC is a peak, so it's what is the value at the address on the top of the stack, and exclamation mark is take an address off the top of the stack, take a data value after that, write the data value to the address, and then there's C at C exclamation mark are the same but for bytes rather than words. Yeah, raw PostScript is good fun as well. I did some of that at university. There was a in the first year, for people who had no programming experience, you went on an introduction to programming course, and for those of us who had programming experience, were given a software project to write, or a basic project to write in the first semester, to make sure we knew vaguely what we were doing, and it was to parse a logic expression and emit it in its simplest form. And I think you could, if you wanted to, go on to print it out as I can't remember if it was part of the assignment or something I did for fun, but printed it out as a schematic by writing the PostScript, and then I got bored and wrote the actual logic reduction in the PostScript as well. But yeah, it's been a long time since I've written any PostScript. It was fun though. Right, so we just need to write the handle specials word now, so we'll do that with handle shifts only. And what that's going to take on the stack, it was 2 words, wasn't it? And it was going to be handle specials debug ... It takes 2 words, and I can't remember what they were. So now we should be able to type hello fine if we press shift. Don't know what that noise is outside, I do apologise. So we are seeing F1 and F. So the top word on the stack is the special key code being handled, and the second one is excuse me, I'm just going to have a look and see what on earth this noise is. Sorry about that, folks. No, it was, I think it was a low loader. I don't know whether they were taking someone's car away or something, but it was making a hell of a racket. Couldn't work it out through the peephole on the front door. Went to look out one of the upstairs windows and it was gone. So, strange. And hello, Willican. Good to see you. How are you doing? No, it's definitely still out there. Why could I not see it from the upstairs window? I am very confused. Anyway, back to this nonsense. I don't remember why you've got F1 showing up there, so let's just have a look at the keyboard table quickly again, because I've obviously made a mistake. So 3.3 is FO. B3 is FO, so we've missed one. We have missed the right shift key is that should fix that. Key table 100. Good. So we was handle specials shift. So we expect on the stack key down and special code. What time is it? It's 20 past 7, so okay. We should just be able to get this working today, hopefully. Is that right? Key down, special code, dot, dot. Yes, okay. And we're calling into this when it is F0. We know we've got F0, so we can say duplicate the code F0 equals if so if special code is F0, then it's a shift. Swap. No, we can do better than that. We can just drop. So now we have just key down on the stack. If the key is down, then we want a 1. No, if key is down, then we want shift state. Yes. Shift state get. There is a actual word to do this in one operation. Can I remember what it is? Add store address amount to add. So it is, if the key is going down, then it is shift state add store. Yep. Else key is going back up again, so it is 1 shift state subtract store. So is that right? Duplicate it, F0 equals, drop the special code. Otherwise, so now we just have an unknown shift or an unknown special operation, so we'll just drop it and we'll be done. So will that work? Handle specials shift is handle specials. Test loop. Well, there we go. that was actually easier than I thought. Apart from the false start. So thank you for Jenko to pointing out that you can just count the number of shifts that are being held down. So let's check that actually works. So no shifts, 1 shift, two shifts, back to 1 shift, back to no shifts. Excellent. Yeah, the shit state of the system could be a valid keyword indeed. Let's catch up on chat. Rarely get bin lorries at 20 past 7. Well, it depends where you are. Around here, you definitely don't. They're at 10 o'clock in the morning for on recycling weeks. My brother regularly gets them about 11 o'clock at night. The noise was Carly trying to deliver a pizza. Well, possibly. I would take a pizza at this point. Yes. Does the keyboard have both a shift lock and a caps lock? It currently has caps lock, which is a pain because implementing shift lock is a bit easier. How can we implement a I would indeed take a pizza at any point. How can we implement caps lock? Well, caps lock is a pain because obviously you need to only apply it to the alphabetics. How can we... Unfortunately, you can't get the original code back. It gives you this sort of disassembled version. And I don't much fancy working my way back from that at the moment. Well, if caps lock set the shift state to -1, then pressing shift on that would bring it round to 0. We could try it. Oh, that's again not useful. Okay. Specials caps. Yes, Matt, that's what I'm going to have to do. That's why I wanted to have a transcript running so that I can actually get this for future reference, but the bits didn't arrive in time, as I mentioned earlier. So it was... like that, wasn't it? So we can say duplicate it, F0 equals if. So if it's the shift, then we can drop. If key down, then go, that's more compact. And then we'll say exit. If it is instead F8, then it is caps. So we want to drop the code. If it's a key down, then we want to get shift state, invert it, write it back. So now I'll have consumed the special code and I'll have consumed the key down, so that's good. And we didn't need that exit, but it'll do. Well, it's easier if we did, and then we can drop to get rid of the stuff that's left on the stack. Right. So then we just need to put find the caps lock key, which is going to be that's 3132, and put F8 there. F8 32 KB code, and we should probably put it at a shifted version as well, just to be safe. Handle specials, caps is handle specials. So now we should still have... Oh, that was interesting. Why did I get 2 character returns? And shift is not working, so there was something wrong there. What did I do wrong there? Oh, I mean, Matt, that was the plan, yes, I just don't have the right cable. The VT420, VT240 has a 9-pin serial port for the printer, but it predates the IBM AT standard for 9-pin serial ports, so I see what I've done wrong there. I was attempting to be too clever, and unfortunately I was insufficiently clever. I shall highlight the line that I got wrong as I get there. And this was it. I put the 1 and the shift state on the stack so I could do that trick with the if key down then do 1, otherwise do the other. But of course that's pushed key down 2 entries down the stack. So what we want is if 1 shift state add store else 1 shift state substore, then exit. That's more like it. Now we can say if it's the F8, well, F8 code, then get rid of the special code because we know what it is. If it's a key down, then read the shift state, invert it, write it back, and we're done. Otherwise, get rid of the junk on the stack. Right, now handle specials is handle specials. Let's see if that fixed it. So does shift work now? Shift does work now. Does caps lock work now? Caps lock works. But it's a shift lock because if I do 1, 2, 3, but that's fine for the time being. Can we do a shift? We can. and a second shift. Well, shift lock was easier than I expected. Caps lock will be a pain because caps lock has to only apply to the alphanumerics. So that will have to be tracked separately. We can't do the same trick with just inverting the state. Anyway, I shall just take a moment to catch up with chat. The easy, lazy way is to just have a caps lock table and a caps lock shifted table. Caps lock table, yeah, that would work. How can we do that? If I'd thought ahead, I could have deferred the KB table words that we could override it now, but we can't, which is a shame. I mean, it is ASCII, yes. We're not quite there, Season B, no. And hello, if I haven't said that yet. Good to see you. I can show you why not. If I bring up... There's the fourth code, or the fourth interpreter itself. And the I/O routines are actually written in assembler for this one, because there are no routines to call into anywhere to do serial I/O, so they're just in a separate source file. So what I need to do somehow is write a trampoline to get from, where is it, I/O, not print string, I/O read line, there we go. The only input primitive it has is read a line of input, and all we're doing is waiting for bytes to turn up at the serial port. So what I need to do is extend that with a jump into fourth. What time is it? It's 25 to 8. Yeah, unfortunately I'm not set up to recompile the fourth. To recompile it with a trampoline in place, which is a shame. I was hoping to be, but the connectors I need to build an extra cable didn't arrive in time. So we'll do that next time, maybe. Just trying to think where we can go from here in 25 minutes. Just catching up on chat in the tiny window I have on screen here. Yeah. I'll wait until we're back from ads, because I see we're in ads before I address a couple of comments there. So, can we implement an ASCII is alpha? And where would it live if it needed to live somewhere? Need to press that first. Yes, indeed, hot rocks. Off the rail bridge, preferably. I'm just trying to think. I don't think I want to, because I'd have to rewrite the... Where are my notes again? Where are my notes? This is all... the thinking I had a couple of weeks ago on it, but we'll switch back there. It would have to live in the decode. No, I think what we're going to do is we're going to leave that there for the time being. I mean, writing the is alpha is easy enough. It's where I hook it in to the decoder is the bit that gets annoying, and because it means having to retype the entire handle specials. God, beg pardon. Not handle specials. The routine that calls into handle specials, that would need to be rewritten to take into account the fact there are 2 types of shift now. So we'll leave that as is for the time being, I think. Sorry, I'm just going to grab a glass of water. Anyway, to catch up with chat there, Phil, yes, this is indeed Forth. It's a port of Jones Forth to my homebrew machine. So it's Forth running on a bunch of 7.4HC logic, basically, and it's doing surprisingly well for what it is. I think what we want to do is actually, we're missing one crucial thing, which is a caps lock indicator. There is room for one on the board here, but I haven't fitted it yet. Because I still need to choose a colour of LEDs. So let me just grab something to show you all. That's the prototype board. You can tell it's the prototype because it has bodge wires on the here, where I took the wrong phase of the clock out in the for the shift register, so I had to rework the other board, and it's got all sorts of diagnostic probes on the back. But the other thing it has, 3 LEDs and an HDSP 2112 dot matrix display. So let's briefly see if we can talk to that display, or turn those LEDs on and off. Yes, RF. Swarm of Dead Insects has it. It's, well, it's more bare bones than basic. It's more capable than basic, but it's a lot simpler to implement. So you can bring it up in very little code on a new system and then use it to write the rest of the system if you wanted to. I probably won't be. I'll probably be writing a lot of the finalised software for it in assembler just for speed, but it's doing quite well at the moment. But yeah, you can do a lot more with it and faster than in most interpreted languages. Well, certainly in this sort of level of computing. So let's just try this quickly. Unhook the keyboard and plug it in. Come on. Test loop. That's probably going to spew some nonsense. Okay, that prototype keyboard still works, which is good news. So what we want to do is see if we can turn those LEDs on and off. If I could type, it would help. So we have a 6 at KB status. What's a 6 mean? Hi, the Industrial Sand. How are you doing? Good to see you. So a 6 on KB status is... Oh, the 2 config straps are set on the back, that's why. So I should... The noisy people are back. Ah, God, sorry, I forgot you were not on the... There we go. With no keycaps, I just type nonsense, obviously. So the 6 are just some ident codes that to identify it as the prototype, and then in theory, if we set the top 3 bits of the status, I think it is 5, 6, 7. Yeah, we should be able to turn the LEDs on and off. So let's give that a go. Hang on. Well, the numlock light didn't come on. Where's numlock supposed to be? Numlock is Q3 D5. Oh, well, that's unfortunate. But you should be able to see we have LEDs at least. These were when I was auditioning different colours of LED to see which ones I wanted. And the pale blue, pale white and green looked quite nice, but they clashed with the display. So what we'll do is see if we can bring the display up. So first I need to find the datasheet for the display. Broadcom now. God, Broadcom buy everything. Good. So where's the register reference for this? Sorry, bear with me. Control word data format. So we'll write a control word. Sorry, let me find OBS again so I can see what I'm doing. Numlock should be a white LED. Either I have shared a resistor off the back, maybe? No, doesn't look like it. Okay, well, let's do something stupid and just write all F's to the status register and see what happens. No. It's obviously just gone pop somehow. So what we want is to write we need 2 new addresses. Oh, that's not fun. And they are at, sorry, I'm just looking at my schematics for the thing. Address is at 2. And then data is at 3. So with that we should be able to reset the display by sending... Reset is D6. So if we send naught, and we'll just write a 0 to it for the time being. 0 to DSP adder, and then we need to deassert reset, which is bit 6, so it'll be 4, and deassert flash as well, so 60 DSP adder, right. So that should have initialized the display. And then the control word is at 70. Yeah. And then what do you do here? Do you do that and then write to the display? Yes. And the control word needs to be... Let me just bring up the datasheet so you can see it. That one, I think. And we're going to set normal operation 0, normal operation 0 there. So 0, 0, 0, BL, disable blinking, disable flash, yes, and we'll set it to 40% brightness, so it should be 3 DSP data right. So that should have enabled the display, at which point we want to write character RAM so 7 gets us to there, and then it'll be from 7 8 should be the first character, and we'll put an A in it, and we'll see whether that actually shows up. It does. You cannot see it, but it says A. So we could write a DSP char that takes a ASCII and a position, and then say 78 plus DSP adder right, DSP data right, and then we should be able to say there we go, there's a B. So a quick loop to say from naught begin duplicate 8 less than while duplicate A plus duplicate A plus swap DSP char 1 plus repeat, and that should A, B, C, D, E, F, G, H, yes. I don't know whether you can see that very well from up there, so let me just... It's a bit on the bright side, isn't it? But to be honest, I was hoping that would kill more time than it actually did. But this leads me with the conundrum, which is this. The whole of System 1 is built around basic 74HC series logic chips. The only programmable devices in there are the ROM chips for the boot ROM. And of course the character generation, the character generator ROM for the text mode will be programmable. I don't know whether that display counts as a bit too complicated for it, whether it's a cheat. I would like to have it on there, but I feel like it makes the design somewhat impure. So what I'm thinking is, first off, that I need to decide whether to fit that to the actual keyboard or not, which will influence what colour LEDs I use for the caps, num and scroll indicators. Or maybe what I do is fit sockets to the real keyboard, so that I can remove it if I need to or want to run it as a purely logic only system. So I don't know. I'll throw that open to chat, so you can offer your thoughts as to whether this is something I need to worry about or not. And I've just noticed actually Dopaz sent a giant emote 35 minutes ago, so sorry for missing that, Dopaz. But thank you for the 30 bits. No, the keyboard is definitely not getting a ZIF socket for an EEPROM writer. Go without the keyboard display. Oh, is that OR as in XOR? Or is that OR as in AND? Because of course the spot is there on the PCB. So it's just a question of whether I stick anything in it, to be honest. Well, I mean, I have lurking around here somewhere the actual EEPROM writer, and there are ZIFs on the ROM board, just lurking in there somewhere. You might just have to make out the ZIF sockets that the ROMs sit in. You raise a good point there, Swarm Dead Insects. It is actually possible for the machine to query whether the display is fitted. Well, not the display itself. The display, neither here nor there, but up here, the two chips, these are the actual interface of the display. This is a register to hold the address that's being accessed, and that's the read back for it. If those chips are fitted, then the machine can tell that they're there. If they're not fitted, then there's a bit that will be 0 in the status register. So I could design it or write the software such that if the display is present, the LEDs are dead. So if we did DSP status, no, KB status, isn't it? So you could have it with the LEDs disabled if the display is fitted. That might work. So I shall give it some more thought. Where are we at? We are at 3 minutes to 8, so Shelby is imminent. Matt, I appreciate the suggestion, but absolutely not. No. that would be disastrously bad, I suspect. So let's just have a quick look at this. So I suppose I shall start wrapping up, and then by the time I finish wrapping up, Shelby will be around to raid into. So thanks for joining me for that, folks. It was well, I enjoyed it. I don't know whether any of you enjoyed it. It might have been baffling nonsense, as I suspect it probably was, and painful for those who actually know Forth to watch me struggling with it. But we achieved what we wanted to achieve, and we can type nonsense now. And typing nonsense is always a good thing. I don't know when we'll be looking at System 1 again. Next, on Tuesday, we will be looking at RC 2014 build again. We'll be doing either... I think we'll probably do the compact flash board, which is fairly straightforward, and then boot into CPM, to see how that goes. Or we might do the VGA board, which is just a basic terminal that you can use on it, but I don't know. It'll be one or the other. I shall decide over the weekend. Next Friday, we are looking at the pile of stuff I picked up last Friday on Shelby's behalf. Having looked into it further, it's not what he thought it was. Or there were some bits of it that he thought might be interesting, that he'd been after for a while. And by the time I got them home and dug into them, it became apparent that they were not what he thought they were, so he doesn't need them. So on the plus side, that saves me the hassle of shipping a large pile of stuff over to the US for him. On the other hand, it means that they're now mine, taking up room in the living room at the moment. But we'll take a look at them next Friday. Some of you might find them interesting, some of you might not. It's certainly something to play with anyway. One of them is something I've been after for many, many years. Well, no, not been after. I could have bought one at any point in the last many, many years. It's just I never wanted to spend the sort of money that a working example goes for. And this entire pile cost about the same as a known broken example for parts. And it turns out it works mostly fine. We've got some repair work to do on it, but it should be fairly straightforward. Yeah, so I'm looking forward to that. We'll see what you make of it then. But I suspect Shelby is about to start. It is 8:01, isn't it? So I shall get ready to rate him. Future work on System 1, I'm not entirely sure. We've got the keyboard working, demonstrated it works. I could do a stream integrating the keyboard with the fourth I/O layer. Perhaps that might be... It'll give you all a chance to see System 1 assembler. So I'll think about that. Other things we could do are the display board for it, but that's a massive project. I need to think about that some more. So as I said, not entirely sure when we'll get back to it. Maybe week after next. But yeah, we'll see. RHK, the PCBs were from Elecro. Purely happenstance as it happens. I was looking to... There was some other board I wanted to build, and I went to check that the price I had in mind for it was still accurate, that they were still yeah, I went to get a shipping quote or something from them for some basic board, sort of 10x10 2-layer thing, and they had a big promo on their page at the time saying for Easter, this is 2023 I think, or 2, ages ago anyway. I can look that up, it's on the back of the board. They had a big promo saying for Easter, mechanical keyboard extravaganza, PCBs up to 1 metre on a side, I think it was $10 for 10. So I was like, okay. Date 2023-0427 is the final revision date on this PCB. So because I'd already bought the keycaps, I figured I might as well build the board if I can get the PCB made for 10 quid. So I did, and I had some left me with some spares, so I designed it so it could be cut down and fitted into a 3D printed frame for a smaller desktop version for reasons. And unfortunately, I cocked up the design of, or cocked up the file I sent them to laser cut some acrylic for the top, and there are all sorts of problems with the smaller versions, but the big version works nicely and was nice and cheap, so I was pleased with that. But yeah, I am going to raid into Shelby even if he is buffering like crazy. Let me just pull up Twitch so I can have a look. And the reason I'm going to do that is because I am running out of things to say, as you can probably tell. Oh yes, we do have... Oh, I see what you mean. Yes, that is absolutely dreadful, isn't it? Okay. Maybe we'll sit here for a minute. RHK, it was you who asked about the toggle switches, wasn't it? I shall go and look those up once I finish the stream and send you a whisper if that's okay. And in the meantime, I am going to raid Shelby now, even if we're going to land in the middle of that stuttery intro, because my mouth is dry and I need some food. Dinner is probably going to be some chicken thighs in hot sauce of some sort, Matt. I shall figure it out in a minute. And chips, of course, because chips on a Friday. So anyway, thanks again for joining me, folks. Let's go see how badly Shelby's stream is performing, and I shall catch you next Tuesday or Friday, whichever.